Unit 6, Lesson 10, Partial Fractions and Long Division. So in our unit on integration, we found the integral of rational expressions such as this right here. The reason why this one was so easy is because the derivative of the bottom was the top. So look, if I take that x squared minus 7x plus 10, and I take the derivative of it, 2x minus 7, that happens to be what my numerator is, and I'm going to have canceling. So this was easy U substitution, okay? But now we need a new approach to integrate rational expressions, such as the integral of 2 over x squared minus 1 dx, or the integral of x minus 1 over x squared minus 7x plus 10 dx. This one would be perfect had this been a 7. If that right there was a 7, we would have been good to go, but it wasn't. So we have to have a new way to integrate that. And so, or this one, previously, this third type, we used long division, okay? So it says, in a proper rational expression, the degree of the numerator is less than the degree of the denominator. So, of course, this one is proper because the degree of the numerator is less. This one is considered a proper rational expression because the degree of the numerator is less. But then the improper rational expression, the degree of the numerator is greater. So this one is considered improper. And we may use long division to obtain the proper form. So let's consider a proper rational expression shown in the equation below. And notice how they've separated that into two fractions. Okay, what they did was they said, well, I know that this is equivalent to 2 over x minus 1 times x plus 1. So they were able to factor that denominator. And then they said, you know what? I know that this could have started from a over x minus 1 plus b over x plus 1, because you could have had those two fractions and then found that common denominator and added your numerators over one denominator. So you can split these up into two separate parts. And there is a technique for doing that. You can see that well, they did plus and minus there. Sorry about that. So their A was -1 and their B was +1. So they found out, so I'm gonna show you a technique on how to find that A and B. Okay, that's what partial fractions is. And so this is called the partial fraction decomposition. And that's what we're going to be doing to solve these integrals. And so we go down here, and by the way, AP Calculus, it will only give you linear factors in the denominator and non-repeating, because when it's non-linear or when it's repeating, there's a different way to do these. So we are going to focus on just the ones where it's like this situation right here. So if I wanted to figure out what this A and that B were, I am going to say, well, if I did this correctly, I can take my A times the opposite denominator plus my B times its opposite denominator and set that equal to whatever my numerator is here. So I'm setting that equal to 1. Okay, so again, it's almost like this, where if we were finding common denominators, we would go like that, and we would go like that, and A times x minus 2 plus B times x minus 5 is going to give me 1, because when I add these together, they're gonna have the same denominator, so I'm gonna be able to add my numerators over one denominator. It's going to give me that same denominator on both sides, and so my numerators are gonna equal 1, my other numerator, because the denominators are gonna be the same. So it would give me something like 1 over x minus 5 times x minus 2 is equal to A times x minus 2 plus B times x minus 5 over x minus 2 times x minus 5. So, so you could see that the numerator is going to equal the numerator, the other one. Okay, so that's what I'm doing. I'm just not showing all that work. Okay, I'm just showing, so I'm going to erase that because it's going to get in the way. So I'm just showing that part, taking A times x minus 2 plus B times x minus 5, setting it equal to 1. Now, I'm going to say if my x is 2. Well, look, if my x is 2, my a turns to 0. It takes out my a. But my b is negative 3b equals 1. So my b becomes negative 1/3. If x equals 5, my b is canceled out, but my a is 3a equals 1. So my a is 1/3. So now I could actually rewrite this, and I'm going to put it over here just because I ran out of space. And that is equal to my 1/3. And guys, you can put it like this, 1/3 over x minus 5 plus negative 1/3 over x minus 2. Or you can write it as, pulling it out front. Okay? Now, I do want to tell you that when we are doing these, it's going to end up going like that. Look, it's going to be like an integral. You're changing this, and once I find my a, if I pulled my 1/3 out front, this would be integral 1 over x minus 5 dx. And then I would split this up, although I probably would make that a minus because my b is negative. So minus 1/3 integral 1 over x minus 2 dx. So, if this was an integral equal to an integral, you're substituting it in because those are equivalencies. Like if I took this and simplified it, tried to find a common denominator and everything, it would simplify to that. Okay, those are equivalent. That's why I'm able to, if I was integrating here, I'm able to say it's equivalent to that. And then this is, of course, an easy integration because it's ln, absolute value of x minus 5 minus 1/3 ln absolute value of x minus 2 plus c. So it's, once you get it to that point, it's pretty easy to integrate. Okay, so let's look at example number 1. So I'm going to do it in a different color just because I've written all over this. So I'm going to do it in red. Okay, so the first thing I'm going to do is factor. I see that this is factorable, x minus 2 times x plus 2. And now I'm going to write it as a over x minus 2 plus b over x plus 2 dx. Okay, I know that I can do that. Now over on side work, I'm going to take a times x plus 2 plus b times x minus 2 and set that equal to my numerator of 1. And I'm going to say if x is negative 2, it's going to cancel my a out. But what happens when I put negative 2 in for x for my b? It becomes negative 4b equals 1, and my b becomes negative 1/4. And then I say if x equals positive 2, which would 0 out my b, my a would become 4a equals 1, so my a is positive 1/4. So now I can say, okay, that means that my integral is positive 1/4 over x minus 2 plus negative 1/4 over x plus 2. And so once I have that, I can split these up into 2 separate integrals and pull that constant out in front and see how I'm splitting it up into those 2 separate integrals. And now I can easily integrate. I have 1/4 ln absolute value of x minus 2 minus 1/4 ln absolute value of x plus 2 plus c. Okay. So that is the technique for partial fractions. So this is proper, right? This is a proper rational. And so, and if I took the derivative, like, you should always think of u substitution, but when I look at it for u substitution, I have to say, no, because my numerator isn't 2x minus 7. If my numerator would have been 2x minus 7, I would have been good to go. So now I'm like, well, I hope that I can factor my denominator. Because if I can factor my denominator, I can use partial fractions. And I see, how about a negative 5 and a negative 2? That gives me positive 10 when I multiply and negative 7 when I add. And so now I say, okay, well, I want to make this into a over x minus 5 plus b over x minus 2. I just have to solve over here in side work for my a and b. And so I know that my a times x minus 2 plus my b times x minus 5 is going to equal my numerator of x minus 11. So now I just look for the 0 of the first one, and my 0 would be x equals 2. So that zero's out for my a. My b becomes negative 3b, right? Because if I put a 2 in there, 2 minus 5 is negative 3 times b. And then if my x is 2, I have to actually put my 2 in there. So that's going to become negative 9, and then when I divide by negative 3 on both sides, my b becomes positive 3. And then I say if x equals 5. If x equals 5, my b goes away. My a is going to be 3a equals, and then put your 5 in for x, 5 minus 11. Oops, sorry. So 3a equals negative 6. Divide by 3, your a is negative 2. So now you've got your a and your b. So you can say that your integral is negative 2 over x minus 5 plus 3 over x minus 2. And now you can split these up and pull your constant out front. Split them up into two separate integrals, pulling your constant out front. So negative 2 times the natural log of the absolute value of x minus 5 plus 3 times the natural log of the absolute value of x minus 2 plus c. And then, that's an okay answer, but these might be on multiple choice problems. These might be on multiple choice tests, or it might be a multiple choice type thing. And this is also equivalent to ln. Now remember, if it's negative, it's in the denominator, and I can put that 2 up in front. So this could be the absolute value of x minus 5 squared in the denominator, and then I can bring that 3 up front for the one that's positive, and it stays in the numerator. And we could also write it like that. Okay, so that's another way to write your answer that you have to remember from your logarithm days and all your logarithm rules, okay? Because it might be a multiple choice problem, and you might have to look. It might not have this one. It might only have this choice. So you have to be able to move from one to the other. Okay, next one. Again, this is proper. And the derivative is 2x plus 3. I probably would be thinking about, well, if I factored a 3 out, would it then give me it? And it doesn't, right? So it's going to be x 3 times the quantity x plus 2, so that still is not the derivative. So that tells me that I have to use partial fractions. So I'm like, well, I want this to be, and if you want to, you can go, before you do this, x times x plus 3. So I want this to be a over x plus b over x plus 3. And your side work is going to be a times x plus 3 plus b times x equals 3x plus 6. And we're just going to say, well, what if your x is negative 3? Well, then your a goes away. And this is negative 3b equals, and then remember, put your negative 3 in for the 3x plus 6, put it in for x there. So this is going to be negative 9 plus 6, so negative 3b equals negative 3, so b is 1. If x equals 0, that would zero out your b. You would get 3a equals 6, because your 0, 3 times 0 plus 6 is just 6. So your a is 2. So that means that this becomes 2 over x plus 1 over x plus 3. And now you can factor out the 2 if you want to, put it in front. Split up these two as their own separate integrals. So 2 ln absolute value of x plus ln absolute value of x plus 3 plus c. Now, since these are both positive, you could multiply these. Those are the proper logarithm rules. So this is another way to write this. So either one of these would work. Example number 4, we still have a proper because the degree of the numerator is less than the degree of the denominator. And I don't think I can factor the numerator, so I'm going to leave it the way it is. But the denominator, look, I can factor that again. So this would be x times x minus 2 times x plus 2. So can we do this with 3? A over x, oh my gosh, why do I keep? A over x plus b over x minus 2 plus c over x plus 2. The answer is yes, we can do this. Remember how I somehow added, I don't want to lose it though. Add a page. Okay. I thought maybe I would do my side work down here for this example number 4. This time, I'm going to start further over. I have to take a times x minus 2 and times x plus 2. Plus b, I have to take it times x and times x plus 2. And I have to take c times x and times x minus 2. And it's going to be set equal to my numerator of x squared plus 12x plus 12. So now, let's just start with if x is 0. If x is 0, I get negative 4a. This zeroes out, that zeroes out. And the x is putting 0 in for x here gives me just 12. So my a is negative 3. If x equals 2, a is gone. B is 8b. C is gone. And this one is 4 plus 24 plus 12. So 8b is equal to, that'd be 28, 38, 39, 40. And so divide by 8, b is 5. If x equals negative 2, my a is gone and my b is gone. My c becomes negative 4 times negative 2 is a positive 8. Oops, I wrote b instead of c. Sorry. And then this is 4 minus 24 plus 12. So 8c is equal to negative 8. So c is negative 1. All right, so I now have my a, b, and my c. So I can come up here and I can put them in negative 3 over x plus 5 over x minus 2 minus 1 over x plus 2 dx. And this is where, you know, you pull that, let me just put a line here so I don't get you confused on what I've got going on here. So you pull that negative 3 out front, 1 over x dx. Pull that positive 5 out front, 1 over x minus 2 dx. This one's just going to stay negative 1 over x plus 2 dx. So I just split them up into 3 separate integrals. So negative 3 times the natural log of the absolute value of x plus 5 times the natural log of the absolute value of x minus 2 minus the natural log of the absolute value of x plus 2 plus c. And this answer is one answer that works just fine. But you could also write it as ln. Now, x to the third is negative, so we would say absolute value of x to the third in the denominator. Positive is absolute value of x minus 2 to the 5th power. And another negative is absolute value of x plus 2. And that is just another way to write that answer. Okay, so either way is fine for example number 4, but, you know, just making sure that you understand those logarithm rules and bringing that up to the power and noticing that positives are in the numerator, negatives are in the denominator. Okay, now we're going to look at these improper ones where the degree of the numerator is greater than the degree of the denominator. And on these, we are still going to have to use our long division. Okay, so we still need that. So let's go ahead and do our long division here. And so what times x gives me 3x squared, or 3x cubed, that would be 3x squared. So multiply, I get 3x cubed plus 12x squared. And of course, then I subtract, which changes this to a negative and that to a negative. This one goes away. This is going to become negative 4x squared. Bring down my minus 10x, bring down my plus 15. And then what times x gives me negative 4x squared? That'd be negative 4x. So I've got negative 4x squared minus 16x. But then I subtract, which changes those signs. So this one goes away. This becomes positive 6x plus 15. And what times x is positive 6x? That'd be positive 6. This looks like Christmas. Subtract there, this goes away. This becomes negative 9. And so we're going to say, okay, this is my remainder, so negative 9 over x plus 4 over that divisor. So I know that this up here that I got up at the top is equivalent to this function. So now I can say, I know that this is equivalent to 3x squared minus 4x plus 6 minus 9 over x plus 4 dx. So that is the integral that I can use. Oh boy. Okay, I'm going to have to stop. I've got someone at my door. I will continue on.